So Daisy just summarised very beautifully the fact that we're using more and more energy. Computers are all around us all the time, houses, our cars, our phones. Some people even have computers in their heart, literally. And of course, every time this computer does an operation, it's performing some mathematical calculation. So it might not be apparent to you why that should consume power. If you have a torch, it's clear, because you've got a battery, you turn it on, light comes out. Electricity turned into light. It's quite clear why a battery will eventually drain out. But it's a bit less clear why a computer needs to consume power, because understanding why it consumes power then allows us to try and minimise it. So it turns out that, of course, computers just do maths very quickly. They manipulate zeros and ones, multiply, divide them, add, subtract them, and they just do this blindingly quickly. And that's why the information revolution has provided us the things that it has. Turns out that the laws of physics tell us that every time you do one of these mathematical operations, there is a cost. It's an energy cost. It's a fundamental law of physics that says that every time you do a mathematical operation, you must pay some energy. But that's not the whole story. That's not actually why we're consuming as much energy. We're a long, long way yet from having computers that are as efficient as the laws of physics let us. Who's used a laptop on their lap? It's relatively uncomfortable very quickly, correct? Generates a lot of heat. This is the other reason, and in fact the far more important reason that computers use so much energy. Because when you try and push electricity through a material, push electrons through a material, they meet a resistance. And this resistance, pushing against this resistance, is what generates this heat. And this heat is essentially wasted energy. It's not required for the calculation, but it's part of the way the technology works, that it generates all of this heat. And this is the wasted energy that we want to address within Fleet. Now, the key ideas that underpin Fleet's approach to tackling this problem can broadly be summarised in two areas: new materials and new conceptual ideas. So the new materials is, we heard just a moment ago this phrase 2D materials. This means that you take a metal or an insulator, some kind of substance, and you thin it down till it's a single atom thick. So this is the thinnest layer that is at all possible, because any thinner and it wouldn't exist. So it turns out that when you have this single atomic layer, the way electricity flows through that layer is fundamentally different to the way it flows through a normal wire or a cable. And most excitingly for us is there are certain materials and certain configurations where when this electricity flows through the layer, it can flow without resistance. And so this is where we want to try and build devices out of these materials to avoid generating all of this excess heat. So the second big step forward here is a conceptual leap, and this is around the science of topology. So mathematicians love shapes. It's one of the things they do. They've been doing it for thousands of years. Categorizing shapes, naming shapes, playing with shapes. It's a thing mathematicians do. And one of the concepts from mathematics, particularly to do with shapes, is called topology. This is how do we compare two shapes? Why are two shapes the same? Why are they different? So the classic anecdote from topology theory is that a coffee cup and a donut are the same thing. Now, of course, it's used as an anecdote because that's kind of a nonsense statement. Clearly, coffee cups and donuts are not the same thing, not even for policemen. But topologically speaking, they are. If you imagine a coffee cup made out of plasticine or soft clay, you can squish it and reshape it, and then the handle of the coffee cup becomes the circle, and the result is the donut. There's a hole in the middle, which was the coffee cup handle. And at no point in this deformation, in this movement, reshaping, have you cut it, have you joined it, or have you poked holes in it. So a mathematician specialising in topology says that these two shapes are equivalent. It turns out, and this is the really exciting thing from a physicist and an engineering point of view, is that the science of topology allows us to understand why electrons don't have resistance when they flow in these atomic layers. And so there's this very deep fundamental understanding between abstract mathematical concepts and how electricity flows. And Fleet is using these two things together to try and build new devices, to try and take new approaches to this problem, with the idea that we'll be able to build new types of electronics, new computers, new technology, which in the coming decades and possibly even centuries will then result in us having lower energy usage. So this is the mission behind Fleet. Thank you.